Hello students and welcome to the Automobile Engine class. Myself Shankhu host, Assistant Professor of Automobile Engineering Department at Dr. Sudhir Chandra Sood Degree Engineering College under the JIS group. So students, last previous classes we already started the discussion about the module number 6. And the sixth module is covered the topic that is engine performance and the testing. So in the previous few classes we already covered the various kinds of engine power, engine efficiency, air fuel ratio, MOX test, motor oil test, heat heat balance sheet, dynamometer, and the performance characteristics curve. And then we covered a one numerical. Now in this today's section, we'll continue this sixth module with another uh, numerical. So students, let's start the today's class with this numerical. Here the numerical is really based. The question is that the problem is that the following observation were recording during a trial of a four-stroke single cylinder or oil engine. Trial of a four-stroke single cylinder oil engine. The duration of trial that is 30 minutes. The oil consumptions that is the 4 liter. The calorific value of the oil that is 43 megajoule per kg. The specific gravity of the fuel which is 0.8. The average area of the indicator diagram that is 8.5 centimeter, and the length of the indicator diameter that is also 8.5 centimeter, and the spin constant that is 5.5 bar per centimeter, and brake load which is given that is 150 kg, spring balance reading that is the 20 kg, and effective brake wheel diameter that is 1.5 meter, speed is 200 rpm, cylinder diameter is 30 centimeter, and the stroke is 45 centimeter. The water jacket cooling water that is 10 kg per minute, and the temperature rises is 36 degrees Celsius. So these are the given data, and now we need to calculate the indicated power, brake power, mechanical efficiency, brake specific fuel consumption in kg kilowatt per hour, and the indicated thermal efficiency. So these five are we need to calculate in here. So students, let's start the solve this problem. Data given, number of cylinder equals to 1. Duration of trial. Duration of trial equals to 30 minutes. Then here given that is the oil consumption. Oil consum- consumption equals to, the oil consumption is 4 liter. 4 liter. Calorie value of the oil that is 43 megajoule per kg. Specific gravity is given, the value of the specific gravity that is 0.8. Average area of indicator diagram equals to 8.5 centimeter square. length of the indicator diagram is equals to 8.5 centimeter. Spring constant is equals to 5.5 bar per centimeter. Brake load equals to 150 kg. Spring balance reading is equals to 20 kg. Effective brake brake wheel diameter is given, that is 1.5 meter. Speed 200 rpm. Cylinder diameter, bore, equals to 30 centimeter. Stroke also given, that is 45 centimeter. Jacket of water cooling, jacket for cooling water, that is 20 kg per minute, and temperature rise was to 36 degree Celsius. So these are the given data. Now we need to find indicated power, power indicated power, brake power, mechanical efficiency, brake specific fuel consumption. We need to find out the BSFC, or brake specific fuel consumption. Then we need to calculate the indicated thermal efficiency. So we need to calculate these 5 portions. So students, let's start the calculations. For the solution 1, that is indicated power. So if when we for the indicated power, we know the equation, that is the equation of the indicated power, that is IP is equals to PIMP, or indicated mean effective pressure, into LANK divided by 1000 into 60. Here first of all we need to calculate the PIMP, or indicated mean effective pressure. We need to calculate the indicated mean effective pressure. This is equals to the area of indicator diagram divided by length of indicator diagram into spring constant. So this, now put the value here. The area of the indicator diagram which is given already, that is 8.5 centimeter square divided by 8.5 centimeter square divided by 8.5 centimeter as a length of the diagram into spring constant, that is 5.5 bar per centimeter. So here from this equation we got the value of the pin effective pressure, that is 5.5 bar. Now I put the all the value in this equation. So as a, in the mean effective pressure the value is a 5.5 bar. 5.5 bar into 10 to the power 10 to the power 10 to the power 5, because we need to convert it from bar to the Pascal. Then now multiply into length, stroke length, which is given in the 445 centimeter. So that is 0.45 millimeter. Then the area was to pi by 4, pi by 4 into d square. D means 30 centimeter square. This means put the 30, that is 0.3 square, and n as a n, put it here. There is a 4-stroke engine in the engine. Just put it here, that is n by 2 means 200 by 2, as the number of cylinder that is 1. So from this here we got the value, that is 5.5 into 10 to the power 5 into 0.45 into pi by 4 into 0.3 square into divided by 1000 into 60, and the integrated power, the value of the integrated power, that is 29.16 kilowatt. So the value of the integrated power, that is 29.16 kilowatt. Now coming to the, after complete the first solution, now coming to the second solution. The second solution is basically based on the brake power. Brake power. We know the equation of the brake power, that is 2 pi nt into 60 equals to 100,000. So here torque is not given. So from the place of torque we can put here 2 pi n t into w into r. Put the w into r, and here this equation is also given, looks like that. R is not given, that's why the D is given. So diameter is given, so this is 2 pi 2r is equals to D, and W are given into the two way. So from here you can put the value here one by one. So now put here the value one by one. N is 200, W are given into the two way. Here given the brake load and the spring balance reading. So we have divided it and we got the W. So the brake load, that is the 150 kg, and the spring load reading, that is the 20 kg. And then put the value of D, that is the effective brake wheel diameter, which is 1.5. And one more thing here, this is given into the kg, that's why we need to multiply here as 9.81. So now we calculate this value, pi into 2000 into 150 minus 20 into 9.81 into 1.5 divided by 1000 into 60. The value is value is 20.03 kilowatt. So the answer of the brake power, that is 20.03 kilowatt. Now coming to the solution of the C, that is the mechanical efficiency. Calculate the mechanical efficiency. Here we know that the mechanical efficiency of the mechanical is equals to N eta M equals to BP by IP. The value of the BP of value here, put the value of the brake power. Brake power is 20.03 and the value of indicated power, that is 29.16. And now we calculate it, we got the value, that is 20.03 divided by 29.16, that is 0.687 equal to 68.7 percentage. So this is the mechanical efficiency from this problem. Now coming to the, after solving the three problem, now coming to the solution of fourth one. The fourth one is one to find out the brake specific fuel consumption. So for we know the equation of the brake fuel consumption is BSFC equals to fuel consumption equals to BP. Now here, before we calculate it, we know the brake power, but the fuel consumption is not known. But here in the given equation, we are given that the oil consumption is 4 liter, trial time is 30, trial time is 30 minutes, and the specific gravity which is given, that is 0.8. Now we need to calculate it here. So for the fuel consumption, equals to consumption equals to 4 liter. Fuel consumption is need to calculate 4, which is given that the 4 liter divided by 30, then it is into this 60 to convert it to the kg, into 10 to the power minus 3 into 800. So from there we got that, and the value that is a 4 divided by 30 into 60 into 10 to the power minus 3 into 800. We got that value is 6.4 kg per hour. Now I put the value of the fuel consumption in this equation. The value of fuel consumption is 6.4, and the brake power is already calculated, that is 20.03. So this is equation by 6.4 divided by 20.03. The value is 0.31, 0.32 kg per kilowatt hour. So this is the value of the specific brake specific fuel consumption. Now we need to calculate the fifth one, which is the indicated thermal efficiency. We know the indicated thermal equation of the indicated thermal efficiency is the eta ITH equals to IP equals to MF into C into V. Now here IP indicated power, which is already calculated, calorific value is given in this equation, and mass flow rate is also will be calculated here. So now put the here is 1 by here 1 by 1. The indicated value of the indicated power, that is 29.16, mass flow rate, that is 6.4, already find out, calorific value, that is 43 megajoule, so we convert it into the kilojoule. The value is, now we calculate it, 29.16 divided by 6.4 into 43000. The value is just 1 minute. This MF means the mass flow rate is converted into the kilojoule per hour. So we need to convert it into the second. 3600. Then so the value is 0. The value, that is 0.3814. So this is equals to 38.14%. So students, here we calculate the already calculate the indicated power, brake power, mechanical efficiency, brake thermal efficiency, and the indicated thermal efficiency. So all these 5 parts which is need to be calculated are already find out in here. So students, here in this section we are solving another problem related with the engine performance and the testing. So in the next class we'll do another problem. So still then, stay at home and stay safe. Thank you so much, student.